Precision agriculture, how can we use it for regenerative practices? Here to talk about it, we have Sigu Muringaseril, co-founder and CEO at AgroScience Capital AG. We have Paweł Hersztowski, founder, investor at MeteoTrack. We have Olivier de Clercq, investor at World Fund. And the panel discussion will be moderated by Conan Condon, head of Agri analytics at Alltech. Welcome. Join us. And it looks like we're all set. It's all yours, gentlemen. Enjoy.
Good afternoon, everybody. And we're getting towards the end of the day. But listen, thanks for coming along to join the panel today on precision agriculture for regenerative practices. Today we'll be discussing topics around data, AI, partnerships, and how we use precision tools in a financial and sustainable future. With a brief description of who the guys in the panel is, but I want to pass it over to the guys to give a brief introduction of who you are and what your technologies and solutions have around precision agriculture. So I'll start with you, Paweł.
Perfect. I'm Paweł. I'm a serial entrepreneur from Poland. I have more than 15 years experience of building digital products. After 2 exits from 4 years, I'm a big lover of AgriTech. I would love to be part of this epic transformation. That's why I'm investing, and I'm founder of MeteoTrack, which is a soil analysis-based decision support platform for small and medium farmers. How we drive precision agriculture, maybe I can also answer right now. I love this comparison that soil analysis are like blood tests in human treatment. So you cannot make a precise, safe, and effective treatment without quality health data. So soil condition and the quality data is crucial for almost every precision agriculture operation in the field. That's why in MeteoTrack we cover entire chain connected to the soil analysis, and we are working hard also to build a complex ecosystem to increase accessibility of professional services for small and medium farmers. So no one will be excluded from regenerative movement. Thank you.
So I'm Olivier, have a background in bioscience engineering with a master's in agriculture. I set up a coffee plantation in Congo during 1 year with regenerative farming practices. And then I moved to VC, so today I work at World Fund. And at World Fund we have one big investment criterion, is that we invest in technologies that can save 100 megatons of CO2 or CO2 equivalent on an annual basis. So with that in mind, we intensively also look at agriculture and regenerative farming, because I think there's 2 big opportunities there. Firstly, it can be a carbon sink, not only give a solution to reducing the carbon emissions from farming, but also have a negative CO2 equation. And then also it leads to more resilient agro systems. So especially with my experience in Congo, I think that's quite important in the developing countries to have a resilient system against drought and heat stresses. So this is our scope.
Yeah, hi, my name is Sigu. I have a master in management and a PhD in economics. I'm a co-founder of AgroScience. Within the company, I take care of building and managing the institutional framework around the technical developments of my chemical engineers, biochemists, etc. Our company purpose is to support farmers in the sustainable production of food. fertilizer and plant protection are at the very core of agricultural productivity. Therefore, we design innovations in fertilizer and plant protection. Some of you may know that we expect a regulatory-induced reduction of plant protection offerings of up to 70% in the next 1 to 2 decades. Some of that technology gaps can be, let's say, filled with proprietary deal pipelines through large producers, also through external developers. So we basically develop a chemical active substance group with broad disease control spectrum effects against or for bactericidal and fungicidal application with patents in over 30 countries, including Japan, China, India, US, Brazil, Mexico. So that's one part, plant protection. And the second part is we do produce environmental friendly 2-component, 3-component PK, NPK fertilizers in a very climate-friendly manner. So environmental friendly PK, NPK fertilizers, energy efficient and CO2 neutrally. So that's where basically the second link to precision fertilizing, precision agriculture comes into play.
Thanks, guys. Olivier, will precision agriculture for regenerative practices significantly transform large-scale farming practices, or is it simply just a trend? And even if you can kind of go back to where you said in Congo, you got the small farmer, how do you see the difference, or where do you see that transformation?
Yeah, so maybe firstly on regenerative farming, I think we don't really have the choice to transit into regenerative farming. External costs of agriculture today is 5 times the cost of the revenue. So that means there's a huge pressure on the soil and the biodiversity. So I think in the long term, there's not really a choice of moving to regenerative farming. And then more on my experience in Congo, I think it is a way for the small farmers to have more resilient agrosystems. This, due to climate change, will be more and more extreme weather patterns. So with drought and heat stresses. And regenerative farming gives an opportunity for these small farmers to have a consistent yield and don't have any years without any yields because of these climate change patterns. So I would say it's something we really need on a large scale, especially also in developing countries.
Yeah, the short answer to it is it's too important to be just en vogue, to be unmistakably clear, because climate and environment are common goods. You are a fiduciary of climate and environment to the generations to come. Right? So, and we entail or pass on that fiduciary responsibility as to climate and environment to the generations, next generations, as to the following generations. So, to me, it's not a question of whether, it's just a question of how fast do we set up the requirements required for adaptation of technology. So, certainly, we can start with data, and I think it has been previously elaborated already in the previous session. But we require multispectral imaging. We require machine data as applied, as planted, harvestation-related data. We require, and Paweł will refer to that, soil-related data, moisture, pH values, soil types, etc. So these input data have to be generated and then processed in clouds with the help of AIs, converted into some level of valuable output data, such as variable rate applications or, let's say, field performance, field mappings, and then transmitted through APIs to farmers on apps or, let's say, cockpits and tractors. So data is certainly one of the requirements that will moderate the adoption of technology, number one. Number two, I guess the mindset of industry as such. As I mentioned, we have to understand it's not mine environment and I'm accountable to my daughter. You are accountable to your children. and you will answer that question. So having a new type of cost accounting, not only entailing direct costs of production of fertilizers, but also the indirect cost of application of, let's say, certain inputs of production. So mindsets have to change. The application strategies of farmers have to change, certainly, because so far it's primarily efficiency driven. When you look at large-scale farmers or field applications, and if you take corn, for instance, farmers tendentially fertilize soil with corn seeds when they sow, because it's efficient, one go, you sow seeds and you fertilize. However, when you come to, let's say, phenologically development stages, later development stages, such as, let's say, bud development, leaf development, branch development, let's say, or fruit maturity, fruit development. So these nutrients may not be bioavailable because some of it may be already fixed with heavy metal oxides, etc., in soil. So I think a more demand-oriented BBCH, crop stage-specific, crop-specific, soil-specific, application strategy, application technologies have to come into place. So there are a couple of factors that have to be met, and for that I would entail a transition period of certainly 5, 10, 15 years from switch to conventional to regenerative.
Thanks, Sigu. And you mentioned soil, and Paweł, with your technologies, like when you're looking at soil sampling data, which is essential for regenerative agriculture, what precision technologies are you utilizing, or what do you see is being utilized out there, and what role does, say, AI and partnerships have in that?
Sure. So we use, for example, GPS-enabled soil sampling. So you have very precise location of each sample. So you can make very precise nutrition maps. You can have very precise fertilizing plans. You can have very detailed variable application of the fertilizers. We can use, of course, IoT. We can use soil scanners to have real-time data for operations which are more time sensitive, like irrigation or fertilization. So you can measure temperature, moisture, you can measure pH to make proper decision. With scanners, with gamma waves, you can see in a very detailed way soil composition. You can see the structure. Regarding other tools like drones with hyperspectral cameras, especially, you can access to really wide range of quality data.
So it's vital, is what you're looking at, sensors and looking at real-time data. What's been the adoption from what you've seen in your region, or again to the panel here? What's the adoption of those technology, those sensors that you're seeing among farmers, producers out there?
I need to say that we are still before the huge transformation, and mostly when I watch Polish agriculture, for example, or European Union agriculture, I think the biggest movement is connected to European Union grants. So I'm really follow the latest protests, right? And I'm really interested in the long-run strategy of European Union, because right now it is one of the biggest factors of mass adoption of precision agriculture here in Europe. So this is my perspective. I don't know how you guys see it.
Sigu, I suppose we look back, and again, do we have an over-reliance on AI, or like how do we bring what the knowledge of the producer, farmers there, how do we bring them together? And like from your aspect again, from the fertilizer and from your business, how important is partnerships along with that? But again, looking from technology, farmer know-how, bring it together with partnerships.
Yeah, I think partnerships are extremely important, and that's not because there's a lack in business or revenue model behind it, but I think there are there has to be a convergence of multiple aspects for that industry to convert from conventional to precision. I don't see a substantially different risk profile in adoption of AI in agriculture vis-a-vis other industries. Risk profiles, to me, algorithmic bias because of based on bad data, etc., etc. These are, let's say, present in other industries as well. However, we require clear questions, clear answers on questions such as who owns the data, what is the value of the data. So then it's about precision of those data, and I don't see as of now answers to that, clear answers to that. So I don't think that there will be a soon adoption of precision fertilizing or precision farming soon.
So yes, I think that's correct. We have a lot of risks connected to AI-powered solutions. For example, as you mentioned, lack of transparency, especially in small and medium farmers sector. The trust is on the low level, so we cannot provide black boxes. I think farmers should really understand how those algorithms works, which data they use, how they make recommendation. I think also, as you mentioned, data privacy is very important topic, but I think it is also matter of education. Like people need to get something, need to try it, to be comfortable with new methods. So I think it is also a government. This is I think place for government involvement to help in this transformation.
But surely we need the likes of AI for precision agriculture, for precision technology. Like how do we build and develop these technologies? But again, I understand that we've got trust as an issue with AI modeling and black boxes, because even the developers probably don't even know what's inside it. So that is a challenge. But I suppose, how do we communicate that to the producers to ensure that they invest in these technologies? Because again, one thing is, farmers can't work longer. They've got to work smarter. The only way we can work smarter is by using AI and precision technology. So how do we get that message? How do we get that communication across of using AI as a prominent device in precision technology?
I don't think that you can motivate farmers to provide additional data without incentivizing farmers. So, and there are multiple ways of incentivizing farmers. When you convert data into relevant knowledge or information, probably they can partake in capitalizing on that information somehow. Because that AI is built on my data too, right? So unless such kind of very simple questions are not answered, I don't see that you, on a broad scale, can collect empirical data to build such robust models. I don't have answers, to be honest, on that.
Good. Olivier, you're the investor up here. How do you assess the value of precision technology when you're investing in companies?
Yeah, so as mentioned, for our fund, it's very important to get these 100 megatons of CO2 savings. So when we look at a certain technology, we look at the use case first. And I think what is very important when you look at the use case is that you have an incentive for the farmer, but also something that can, for us then, get to these 100 megatons of CO2. So we need one variable or one parameter that a company looks at and that has huge effect on the farmer profitability, but also on the environment. So one example I can give is, for example, nitrogen. It's 5% of the total greenhouse gas emissions, and about 80% of the emissions could be reduced by only increasing the nitrogen use efficiency. And the nitrogen use efficiency is something that can be improved by precision agriculture. So that's on the environment, and then on the, what is it for the farmer, 30 to 40% of the operational costs comes from inputs. So, and especially with the prices that are rising for inputs, it's a huge concern of the farmers to have alternatives for these nitrogen. So that's something, the use case, in this case nitrogen, is very important to look at. And then also, of course, the business model. We want the farmer to have the least as possible upfront costs. And one way to do it is, for example, to make the big agricultural players take the burden and use this as a strategic investment, so that, for example, a agricultural big ag player would sell their product with a service of precision agriculture, so that a farmer doesn't have to pay the burden of or the cost of the precision agriculture. So those two things, the use case and the business model, are quite important, I think.
I'd like to add one aspect which is equally important in the discussion of precision agriculture. Precision agriculture is primarily about efficiency, right? So improving on the input-output relations. And I can reduce, under ceteris paribus, under the same conditions, I can reduce the external costs, let's say, of food production, by which I improve the efficiency, if everything else remains the same, right? So, but our approach is a bit different. We don't want to sell old wines in new bottles. Ideally, you can combine two things. A more, let's say, demand or need-oriented application of plant protection, fertilizers, etc. So, as it been conceptualized in precision agriculture, but with a new generation of products, which will help to reduce those external costs I was referring to in the beginning, in terms of, let's say, acidification of soil, accumulation in soil, residues in water, residues in agriculture produce, which generate greenhouse gas emissions while being produced, etc. So, ideally, for agriculture to transit successfully, it's not only this concept which has to be applied, but it has to be combined with a new generation of products, and then farmers certainly will not go on streets and protest. Because, if I may add, the reason why these farmers in Germany and other countries of parts of Europe went on streets is because they have been forced to internalize costs which partly have not been caused by them, right? So. Instead of forcing farmers to internalize external costs, help develop technologies which will reduce external costs per se, and then you have to not force them to internalize them.
That kind of brings it back to a point. I was speaking at a conference last week, and there was an Irish dairy and pig farmer that was on the panel, and he was asked a question about what's your return on investment for AgTech, to invest in AgTech? And he says, if I can return investment in 12 months, no-brainer. 2 years, it's a good deal. But anything over 3 years rings alarm bells, saying, why am I going to invest here? And based from the climate farmers at Boston Consulting Group, they reckon that you'll 60% more profit from regen ag, but it'll take 6 years. So how do we bridge the gap? Like, how do we bridge the gap that allows the farmer producer to invest in precision agriculture to get a return on investment quicker?
I think it's a cash flow problem, right? Who will pay for it? I think what I can add is we can speed things up, right? I really believe in hyperspectral satellites. So in my opinion, we should put more money to get quickly commercial, cost-effective, hyperspectral camera satellites, so we can enable some practices without physical sampling. So it will reduce the cost of the transition. Regarding other topics, I think it's part of the also Green Deal, right? We should really keep our fingers crossed to get more programs which support this transition, and also build new business models so we can share the cost between all the actors of the ecosystem, right? So I think it's social agreement. It's huge. It's very hard to manage to build something successful, but I think we need to all be part of it.
So I think from a purely, mathematical or finance mathematical point of view, either if you want to shorten or reduce the amortization period, either you reduce the cash outflow or you increase the cash inflow. Right, so the net cash inflow. So if you want to reduce cash outflow, I mean, that is clearly defined by the capital expenditure. So how much capex do you require for adopting precision, let's say, agriculture? So cockpits, for instance, spraying technologies, mixing tanks, etc., etc. So capex on the one hand, and then on the net cash inflows, it depends on what kind of cultures, the commodity price for that cultures, and the operating expenditures for running these precision agricultures periodically, etc., etc. So it's very difficult to say, because, and that will therefore differ for large scale, where they have large capex and higher opex, but also higher inflows, sales side, right? So for small scale, but I think 6, 5, 4, whatever period that is for any farmer, particularly for medium and small, is is unacceptable. So if that technology has to be adopted, particularly during the initial phase of diffusion, we would require some form of incentivization or subsidies or whatever for those farmers who can bridge that additional, financial gap of adopting precision.
So there's more risks for farmers not adopting precision technology than adopting it. I think that's what we're kind of in agreement here. While the return on investment might take a bit longer, we need to help farmers to invest in these technologies. Just quickly, just to wrap up, just quick fire answer to each of the panelists. What are the top two precision agriculture technologies that we need to look out for in the next 12 months so that we, as an audience here, can keep an eye out? Paweł?
I think first it will be autonomous farming. So we can fight with global problem of labor shortage in agriculture. That's why I'm keeping my fingers crossed for FarmWise, which produce AI-driven weeding robots, which reduce use of chemical herbicides. And the second is not technology. Again, I will talk about European Union. Let's keep fingers crossed that they will not give farmers money for free, but they will support meaningful programs to really help with mass adoption of the precision agriculture solutions and products. That's it from my side.
Olivier?
I think one interesting topic is soil sensing, because a lot of parameters of the soil cannot be sensed with satellites only. So I think what's important for the future is to have cheap soil sensing instruments. Also to reduce these inputs, which is a win-win for the world and for the farmers, I think. And then also a model or a processing model that can gather information and process it to give some understandable data to the farmer so that he really can take action and reduce the feedback loop as much as possible so that he has this most efficient way of farming and be as close to action to what the plants need as possible.
I would say that all technologies which help to measure the level of bioavailability of nutrients. I would say, yeah, because many technologies can detect, phosphor, potassium, etc. in soil, but how much of that is truly bioavailable for plants, right? So I think technologies which will help to actually detect bioavailable level of nutrients.
Excellent, thanks guys. Yeah, that wraps up the panel, but anybody got any questions from the audience?
Coming up.
All right, thank you for all your discussion. My name is Samuel and I'm from Nigeria. So I speak from the perspective of a farmer who've been into regen agri for about 5 years now. And we can literally see the importance, especially to smallholder farmers. What we see with regen agri is that it's kind of climate-based or weather-based, so you can move from one region to the other, and the practice changes. In Europe, America, and most developed countries, you have available data, so this can help you to determine what type of practices to do in one or the other region. As Olivier said, in Africa and most of the developing countries, the available data on regen agriculture is almost non-existent. So my question will be, how can the developed countries help the developing countries in bridging up this gap in order for us to bring home the practices to smallholder farmers? Thank you.
So maybe I can answer. So I think it is a good question. I think it's connected also, Olivier, to your answer. First, we should invest in cheap photospectrometry, so we can have very cost-effective devices who can measure the soil condition in real time. Like, I don't know, in Europe, we have Netherlands, I think, a company called Clercq with mobile scanners, and also mobile lab devices. So we can make PASC tests very quickly. Like, I don't know if you know the Merck medical company which produce this type of devices. So I think we need to invest in all the mobile devices we can, which can really measure quickly the soil in the most cost-effective way. So I think the hardware is the key. The IoT is the key. Olivier?
Yeah, I think we have to be careful in looking at agriculture as a binary thing. It's not only conventional and regenerative. So I think for each place in the world, there's toolboxes from regenerative farming that can be used depending on the financials, climate, soil, very important. So I think agriculture is quite complex, and each place has its own uses. So it's all about getting the most effective agriculture, and that one will be different in Europe as compared to Africa. So get the most effective agriculture in the most sustainable way.
Maybe I can add also that it should be standalone, so without cloud, so you can use it without mobile data. I think we should also consider the mesh networks. So we have a network of IoT devices, IoT sensors, and one of them have internet connection, for example, the rest is using. For example, by LoRa network is the very nice technology for working in a mesh idea, with a mesh idea. So yeah, I think this is our ideas for it. Thank you.